So we are going to start the process of discussing domain and range. And so just a quick review about what we do know from our vocabulary about x's and y's and domain and range. So first off, we know that the definition of domain is going to be all of the x values in a set of ordered pairs. It is also known as the independent variable, and it is also the input of the function. Okay, so those are all of the terms that when we hear each other, they should all kind of relate that x is going to be your domain, your independent variable, and your input. Whereas range is all of our y values, so it's going to be the dependent variable, and it's also the output of the function. Okay, so keep that in mind as we kind of start talking about domain and range. Alright, so kind of walking through these notes, there are a lot of different ways that we'll see domain and range written. And so just as a review, we've seen discrete relations represented in a lot of different ways. We've seen them as tables, as ordered pairs, as maps, and as graphs. So a discrete relation is one where the points are not connected to each other. So if you graphed either of the relations below, it would just be individual points, not connected. So the type of relation you have will help you decide how to write the domain and range. So if your relation is represented as a list of ordered pairs, a table, or a map, the best way to list your domain and range is using set notation because it's a finite number of points, they're not connected, and we can list every single domain and every single range, every single value that falls into that domain and range. So for example, remember here is our ordered pairs, our set of ordered pairs. Each of the x values is here represented. So that's going to be in order from least to greatest, 0, 1, 2, and 3. And then the range values are going to be these right here. And so those are going to be represented in least to greatest, -5, 2, 8, and 10. And remember, we do that in set notation, and that lists every domain and range for that set of ordered pairs. Okay. So since these relations are all discrete, they're just specific points, not a continuous line, we must list the values for x and y, every possible value. Now, with a continuous relation, we graph them as a smooth line or a curve. And so when the function is a line, we can't list all the values because we would have to list every single fraction and decimal that falls in between those main points, and that's an impossible thing to do. So we would need to use a different type of notation. So with continuous relations, we want to use inequalities or interval notation. So we're going to practice using both of those with continuous relations. So we've really kind of already done our discrete and talked about that in the last couple of days, but today we're going to focus in on what happens with continuous graphs and continuous relations. Okay, so we're going to look at the graph to the left and see how we have a line here. So it also has two endpoints. One of the endpoints is here at -7, -3, and the other is here at 4, 7. So our domain, our x values, okay, and I'm going to use a pink highlighter here to represent domain, right? It includes all of the values from on the x-axis, this -7 all the way over to this 4, okay? You see how this is where our line starts, and I'm only dealing with a domain and x values, that's why I'm coloring on the x-axis. And then our line ends right up here, which comes down to 4 on the x-axis, okay? So that kind of highlights what our domain is. Now, our range includes all the values, so we're going to look at our y-axis here. So here's our lowest point, okay, which is right here on our y-axis. And our highest point is right here, and the domain includes all values in between those two. Okay, so that's our range. And I'm going to show it in purple. All right, so the question is, how do we write that? How do we write every possible number in between -7 and 4? We can't list them all like we did in the discrete. Instead, we're going to have to do something to represent all of that. So the best way to do that is using our interval notation and our inequalities. Now, the other part of this question is, how do the endpoints change things? So here, you'll notice we have a closed circle. And just like when we talked about inequalities in the last unit, a closed circle means that those numbers, those values are included in that set. And so -7 and 4 and -3 and 7 are all included in those sets from the domain and range. Okay, so when we write the domain here, we're going to be writing our x value. Notice the x values are between the numbers. It's going to go in the middle, just like our interval notation or inequality, like we practiced before. We're going to use less than symbols, and because it's two closed circles, we're going to use less than or equal to symbols. And just like we talked about inequalities before, we're going to do smallest number to largest number. So the smallest number that's represented here in this domain is a -7. The largest number in this domain is a +4, and that's how far I've highlighted here, because those are the x values that are represented in this diagonal line. In interval notation, we would write that from -7 to 4, and we would use brackets on both ends because of the equal symbols and the closed circles. Okay, so that's domain. Now, notice that with the range, we're going to flip this now, and now we have a y, so this is really important. With range, y is the variable that we're talking about, so y needs to be the variable that we use as we do our inequality. So notice that in our y-axis, the lowest point that we have this graph is at -3, so that's going to be our lowest point, and the highest point is at 7. Okay, and so all of the values between -3 and 7 are included in the range or the y values of these 2 points. So in interval notation, we write that as -3 to 7, and again using brackets because it's equal to symbols and because it's closed circles. Okay, and so we'll practice this more, especially if you're in class today. We're going to do this. There's a Desmos activity. There's also just some practice problems that we're going to work through. So we'll continue to kind of work through this and practice more of these types of questions in class. Now, one more example down here. If we look at the graph to the right, we'll notice that there's a difference between the graph up here and the graph down here. And the biggest difference here that we'll notice is the endpoints. Okay, you'll notice here that we have a closed circle at this point and an open circle at this point. So that means that whatever this value is for the range or the domain is not included, but everything between this number and this is. Okay, so that means we're going to be using some different symbols than we were in the past. So we're going to be using less than and less than or equal to symbols in this case. Okay, so open circle goes with less than, greater than, closed circle goes with less than, greater than, or equal to. All right, so let's look at these domain and range again. So again, I'm going to do domain in pink. All right, and you'll notice that on the x-axis, if I'm kind of scanning up and down from this x-axis, I notice that the first point that I have something show up on my graph is at -6. And the end of this, if I keep scanning, I see I have values that are going to have an x values here in between. It's going to be all the way over, and if I look over here, 6 is my end point. So I'm going to highlight everything in between here. Okay, that's going to be my domain. So when I go to write this, okay, notice that my x is still going to go in the middle, but this time I'm going to use less than or equal to on the lower end and just a less than symbol on the upper end, because here is an open circle. Okay, and my smallest number is -6, my largest number is a +6. If I do that in interval notation, it's -6 to +6, but the +6 has the parentheses that goes with the less than symbol and the open circle. The -6 has the bracket that goes with the equal to symbol and the closed circle. Okay, so a lot of this is stuff that we've done before. What's different is finding these values. So we're looking again for all of the y values for the range that are included in this particular graph. So you'll notice that this graph is going to be starting down here at this -6 and working our way all the way up to here where this graph ends, which across that y-axis is at 0.4. So in between here is where these two lie. Now, we're going to flip over and do our y in the middle this time. Our smallest number down here is the one with the open circle, so we're going to use less than. The greatest number up here has the closed circle, so we're going to use less than or equal to. This lowest y value here falls on that y-axis across at -6. The uppermost falls at 4. Okay? When we go to do interval notation on that, it's from -6 to 4. The -6, because it's a less than and an open circle, gets the parentheses. The 4, because it's a bracket and a closed circle, is going to get the bracket because it's a closed circle and a less than or equal to symbol. It's included. Okay? And so this kind of just shows how far these domain and range go. Now, you need to remember that domain and range must always go from smallest to largest when you have two endpoints. That way we can use those less than and less than or equal to symbols. Now, another type of graph that we may see looks like this graph here to the left. What do the arrows on the ends of the graph mean? Okay, that means it's continuing into infinity and negative infinity. Okay, it's going on forever. That's what those arrows mean. So the question is this a discrete or a continuous graph? Well, the dots are all connected, so this is a continuous graph. Okay. So since the graph goes on forever at both ends, it's going to cover all possible x values because this graph goes out and down forever. So if I were going to represent that on my x-axis, see, this arrow keeps going out forever. So there is no ending point. It's going to go all the way out to negative infinity. So on my graph here, I'm going to highlight on the x-axis everything, including an arrow letting me know that it goes on forever. And that happens sometimes. Sometimes we have things that go on forever. And so you'll notice the domain here in this case is going to be all real numbers. Now if you ever wanted to abbreviate that all real numbers, we can write it as this. Okay, it's a capital R with a real dark line there. Alright, so that's all real numbers. Now if we write it as an interval notation, it's going to be that negative infinity to positive infinity. We've seen that before. And then if we write it as an inequality, it's negative infinity is less than x is less than infinity. Okay, so that's kind of what that looks like. And we'll, again, practice these more in class and in a few activities that we have planned. Now, here we deal with range. So the range, and we'll show the purple on this one, is a little different because you'll notice that my graph, as far as vertical, starts kind of here at this point, the very tip of this, this shape, and it goes down. And now because it's going down and out, it's going to go on forever, so we can also include that arrow going down. But it does have an ending point up here. It has a maximum point. It doesn't have a minimum point. So what happens when we start to draw this out is we have no number. The lowest point here is going to be a negative infinity. So you could write this as negative infinity is less than y is less than or equal to 4. Okay, or you could simplify that and just write it as y is less than 4. All of your y values are less than or equal to 4. Now notice I include the equal to because that 4, there is an actual point on the graph there. It's not an open circle, it's a continuous movement or a continuous part of that line. So we do use an equal to symbol here. But we're going to continue on forever in the negative infinity. So when we draw that as an interval notation, we're going to use the negative infinity to 4, use the bracket on the 4, okay? And so our range shows all numbers that are less than or equal to 4, okay? So this is kind of the brief summary to put it all together on the domain and range. The more that we practice this, the more clear it will become, and that's where being in class is going to be really important. But if you miss, that's okay. Just come and talk to me so that we can get you caught up and make sure that you understand what to do. If you have any questions, let me know. But here's kind of, like I said, our overall notes that come with domain and range. If you have questions, ask them. But we'll be going through this for a couple of days in class. So hopefully, if you're struggling, we can get that caught up for you.